here we have what? We have simply proved the third one, that how it's going to be a subspace. We first check whether the 0, 0, 0 belongs to the set, and we also check the linearity property. So from there we can see that the subspace given in option C is going to be a subspace of R cube, right? Okay, now we have to find the value of the integration. Integration 0 to 2 pi x cube root over 2 pi x minus x square dx is equal to this. We have to find p square plus q square, right? Let's see how we have done it. So we have what? Integration 0 to 2a x cube. This is what we have been given. Now this is our I, right? Integration 0 to 2a x cube x to the power half root over 2a minus x dx. Now we consider x to be 2a sine square theta. The dx will be what? 4a sine theta cos theta d theta. So our I is going to be integration 0 to pi by 2. 2a sine square theta 7 by 2 into root 2a cos theta into 4a sine theta cos theta d theta. So I is what? 64a to the power 5. Integration 0 to pi by 2 sine 8 theta cos theta d theta. So from there we get, we want to find sine I 8, 2, not only I. So from there we put the value, because this is what? This is a gamma function. We put it, and from there we got to be I to be 7 by 8 pi a5. So we have p to be 7, q to be 8. So we have p square plus q square is going to be this particular value, right? So from there we can say that our option A is going to be our correct option, right? Okay. Now here they have given you the the curve, and they are asking you to find the orthogonal trajectory, right? Okay, let's see how we can do it. Okay, now the given equation is of the form x square plus y square equal to constant. If we differentiate it with respect to x, we get what? 2x plus 2y dy by dx equal to 0. So dy by dx is equal to what? Minus x by y. Now, since we are finding the orthogonal trajectory, we are going to do what? We are going to replace dy by dx over dx by dy. And then if we do the integration, so we have minus dx by dy is equal to minus x by y. So we have dx by x is equal to dy by y. And if we do the integration, dx by x is equal to integration dy by y. Now, if we put the log both sides, we get the answer. So from there, we can say that option B is going to be our correct option, right? That is going to represent the orthogonal trajectory. Okay, now you have to show which of the following statement is not correct, okay? So the first statement says that there is 1-1 correspondence between any two right cosets of the subgroup H in group G. So for a subgroup H, we are going to get two right cosets, and there's going to be a 1-1 correspondence. Suppose we are having a right coset this and the right coset this, and they are saying that, oh no, these are not right cosets. Suppose we are having HE and HP, and they are saying that we are going to get 1-1 correspondence between them for any two right cosets we are getting. If you're having H and K are subgroups of G, then HK is a subgroup if and only if HK is equal to KH. Third one says that if H and K are subgroups of the abelian group G, then HK is going to be a subgroup. If H and K are subgroups of a group G, then H intersection K may or may not be a subgroup. So we have to tell which of the following statement is not correct, right? So if we talk about D, since if H and K are subgroup, H intersection K is also be a subgroup, right? So from there we can say that option D is not a correct option, because they are saying that H intersection K may or may not be a subgroup, but it has to be a subgroup. It is going to be a subgroup, okay? Okay, let's move to the next one. Okay, now here we have the points x square plus y square plus z square equal to 1. So which of the points are going to be a maximum and minimum distance from this point? Okay, that's what we have to calculate. So the maximum, if we talk about the maximum and the minimum distance, so the maximum distance and the minimum distance, we calculate it with the Lagrange's multiplier. So we have delta xy is given by lambda xy plus g. The inverted triangle, it represents the partial derivative of the function, and lambda is going to be some constant. Now, if we want to find the minimum and the maximum value of what? the x minus 3 because we have x, y, z points and we want to find the maximum and minimum distance from this particular point. So this is going to what? We want to find the maximum and the minimum of this particular value, right? So our function is going to be x minus 3 whole square plus y minus 4 whole square plus z minus 12 whole square. So this is the maximum and minimum we are going to calculate, and the other function that they have given us is x square plus y square. That is the equation of the sphere that has been given to us, right? Now we apply the Lagrange's multiplier formula, that is a partial derivative of f with respect to x is equal to lambda partial derivative of g with respect to x. Now we do the partial derivative both sides with respect to x. We got it to be x by 3 is equal to 1 by 1 minus lambda. Similarly, we have done it with respect to x. We are going to do it with respect to y and z also. So we have y by 4 is equal to 1 by 1 minus lambda. Z by 12 is equal to 1 by 1 minus lambda. Now we are going to replace lambda by a new constant, that is k. So we have x by 3 is equal to y by 4 is equal to z by 12 is equal to k. So you have x equal to 3k, y is equal to 4k, z is equal to 12k. Now this is also going to satisfy our sphere, right? So we have 3x square plus, that is x square plus y square plus z square equal to 1. So we have 3x whole square plus 4x whole square plus 12x whole square is equal to 1. Solving it, we're going to get k to be plus minus 13. Now, in place of k, we are going to put plus minus 13. So from there, we get the value of x, y, z. So f minimum is going to be what? F minimum is going to be this distance, right? So this is going to be minimum. And f max will be what? It is going to be this distance. So from there, we can say that minimum distance is 12. Maximum distance is 14. And point at maximum distance is going to be this, and point at minimum distance is going to be this one. Okay, now we have that we have to find the value of k such that this function is continuous at x equal to 1, right? Okay, let's see. It's a pretty easy problem. So we have this function. Now, in order to be continuous, the function is continuous at every point except it is having a break at 1. So we have to check whether it is continuous at point 1 or not. If the function is continuous at a point 1, then from simply we can say that the function is continuous on R. So in order to check whether the function is continuous at the point 1, we have to check whether the left limit and the right limit are equal or not. So from there, we check that the left and right limit should be equal. So from there, we can calculate and we can say that our k is going to be 4. So from there, we can say that option D is going to be our correct option, right? Okay, now they have given you a linear transformation r square to r cube and is defined by t of 1 comma 2 is going to be 3 to 1. 3 of 3 comma 4 is equal to 6 comma 5 comma 4, and they're asking you to find the t of 1 comma 0, right? Great, let's see. Now they have given us what? T of 1 comma 2 is this. They have given t of 3 comma 4 is to be this. Now, if we talk about AV1, if we consider 1 comma 2 to be a V1 and 3 comma 4 to be V2, now we are going to try to write AV1 plus BV2 in this format. So V is going to be alpha V1 plus beta V2. So if we take any vector AB, it can be written as a linear combination of 1, 2, and 3, 4. So we are going to find the value of alpha and beta such that it can be written as a linear combination, right? So beta can be written as 2a minus b by 2, and alpha can be written as 3b minus 4a by 2. So we can have t of e comma b is what? This is our alpha into t of 1 comma 2, beta into t of 3 comma 4. So t of 1 comma 0 is what? Minus 2 into 3 comma 2 comma 1 plus 1 into 6 comma 5 comma 4. So from there we can say that t of 1 comma 0 is 0 comma 1 comma 2. It's a pretty easy problem, right? Okay, now let's move to the next one. Okay, which of the following is correct? The CR equation is only satisfied by constant equations. Constant function, if fz is differentiable at a point, then CR equation must be satisfied at that point. CR equations are only used for real valued functions. The CR equation are only applicable for polynomials, okay? Okay, let's see. So from here we can see that CR equations are what? CR equations are the conditions which we define for the complex functions, that a complex function is analytic at a point, it must satisfy the CR equation, right? So it is not necessary that it has to be satisfied. It is only satisfied by constant functions. You cannot say that. Yeah, if a function fz is differentiable at a point, then the CR equations must be satisfied at that point. Yeah, this is going to be a correct option. No, CR equations are only used for the complex functions, because CR equations are the conditions that must be satisfied by a complex function if it is differentiable at a point or not. So CR equations are not only applicable for polynomials, it is applicable for every differentiable function, right? Okay. So option B is going to be a correct option. Yeah. So the reason they have given here is what? So U and V are the real and imaginary parts of the complex valued function. So f of x plus y is can be written as f of x comma y is equal to uxy plus ivxy of a single variable. Z is equal to x plus iy, where x and y are variables. U and v are real differentiable functions of real variables. Now, f is complex differentiable at a complex point. So, if you have function f, it is going to be complex differentiable at a point. If and only if the partial derivatives of u and v satisfy the CR equations at that point. If it satisfies CR equations at that point, we say that the partial derivatives, we say that the function is complex differentiable. Now, if we have z is equal to x plus iy, the complex valued function fz is equal to z square is differentiable at any point z in the complex plane. So fz is what? X plus iy whole square. That is going to be x square minus y square plus 2ixy. Now this u is the real part and v is the imaginary part. So these are given by this. And their partial derivatives are these. So from there we can say that the CR equations are satisfied and they are given by this, right? Okay. Now you have to find the limit of this function. Let's see how we can do it. We are going to find the double limit. So we will do what? We can take any path that is y equal to kx. Now if we are taking a path, we get k equal to 1 by k square. And if the value changes for different values of k, so from there we can say that the limit does not exist, because we are not getting a particular limit. It is changing with different values of k. Okay, now here we are having that V and W are the subspace of R4 and they are defined by these two. Now we have to find the intersection of V intersection W, right? We have to find the dimension of V intersection W. So V is given by B minus 5C plus 2D is equal to 0. And W is given by A minus D is equal to 0, B minus 3C equal to 0. So V intersection W, that means what? All the conditions are to be satisfied. So dimension of W is 2. Now, if we want to find the dimension of W intersection W, V intersection W, it is going to be what? Dimension of V plus dimension of W minus dimension of R to the power 4, that is going to give you 1, right? So we can say that the dimension of the intersection is going to be 1. Now, if we move to the next problem, let's see. Okay, so here we have to find the directional derivative of this in the direction of this at this point, okay? So first we have to find the gradient. So the gradient of phi is given by grad of 2x square yz plus 4x z square. So we have 2x yz plus 4z square I cap plus x square z j cap plus x square y plus 8x z k cap, and at the point 1 comma minus 2 comma 1 is given by 0 plus j plus 6 kk. So the required directional derivative is going to be the dot product of this. So from there we get the answer to be minus 13 by 3. So we can say that the option A is going to be our correct option, right?